Welcome to Inside Builder channel. How LLMs execute code and commands on your computer. Part 9, Video 2. Using Python Exec and subprocess to execute code in Crew AI. In this video, we will be diving into the code execution part of this discussion. We will see how the code execution agent works, and for that, we will see how the code execution tool is implemented. Let's dive into the code part. We have the code exec underscore crew.py. So this is the crew.py file that I am directly showcasing to you so that you guys can understand what's happening. So in interpret underscore code folder, which is part of the GitHub repo that I'll be sharing with you in the code description below, you will find all these files. We are going to execute the code exec crew.py. So what this is going to do is, this particular crew.py is going to find the 10th Fibonacci number. So this is what it's going to find, and let's see what it does. So, and it's going to be in verbose mode, so you will see what's happening at each step. So let's execute. Why I'm actually showing the output in the beginning is to make you comfortable to understand the entire process. So the Python code for Fibonacci sequence will be first of all written, and then that code will be executed by the code execution tool. So you can see the interpreter has started, the code interpreter, and it has written the Fibonacci function. You can see the Fibonacci function in the code area, and you can see the result that has been taken out and the result getting printed. The result is 55. You can check it out. The answer is right because it's actually writing a Fibonacci function, right? And I'm using GPT-4o mini in this case. If you're going to use any of the open source LLMs, there can be some challenges when it comes to writing the code. But yeah, GPT-4 has a pretty good output when it comes to function generation. So you saw what is happening. So the function got written and the function got executed. So both of these things are happening. Now let us take a step back. So what exactly happened? We have to understand how the tool got executed. So tool in Crew AI is basically a function. Yeah, you heard me right. So tool is basically a function. So if you have seen my earlier videos in this series of playlists, you would observe that it is a function, but it has some additional supporting elements that make it easier for the LLMs to call this function. So in order for the LLMs to call this function, first thing is it has to know that there is a function. So that is how we are actually telling to the agent that, okay, you have got some tools, you have got some functions that you can use with the names of the tools. And then we are also telling that these functions will need kind of inputs, the parameters. So those parameters are given through this two different input parameters, the code and the library is used. So this schema, the code interpreter schema, is a Pydantic Base Model which forces the LLM to create an output which has both the code and the libraries used. So this actually forces it, right? So this is one of the point that kept on creeping, like why there is a Pydantic model inside a tool, because the tool needs a kind of an input. So it tells to the LLM, okay, give me this kind of an input. So it is kind of a give and take that happens inside the agent, inside the task, and inside the tool. So it's all together there. So you need to remember that this is what the Pydantic model is doing. And this is where the class is getting implemented. Just a moment ago, I told that a tool is a function, but now I'm talking about a class. Fine, I'm still sticking with that earlier comment. Tool is still a function, right? The class that you're seeing here actually helps the LLM to easily guide the output the LLM is creating or generating to be sent into the function, right? And that function that you're talking about is underscore run. So here the function is actually a method of the code interpreter tool that you see here. So which is actually inverting base tool. and here it is also using the args underscore schema, which is having the code interpreter schema. So now, by now you must have got the idea, okay, why we are using a class. Yeah, we can use a tool, the tool decorator option, but I prefer to use base tool. It is very streamlined, and when you are going to write production ready code, it's better to use the base tool inherited class for the tool. In the run method, what you're doing is we are actually telling that there are going to be two parameters. If you guessed it, it is going to be code and the library is used, right? And we are telling that we have to run the code directly on the host machine. So do not give this particular function to be executed in the host machine. If you are going to write these kinds of function in production, you have to be very careful. In case of Crew AI, they don't actually give you this kind of a tool. There is already an existing code interpreter tool in Crew AI, but it actually runs in the Docker. But my intention was to actually break the entire process and to show you, okay, what exactly happens. Because the Docker Crew AI tool actually has the Docker prerequisite, right? But why to have a prerequisite? You need to understand the things at a much simpler level. So that's why this particular discussion. So here you see that it's trying to install the various libraries by using a for loop. So it's doing a os.system and it's doing pip install library. So os.system is a os module function which executes the system commands. Okay, so a lot of things you're learning, right? And next comes the exec local. So if you see this line 37 to 39, so you'll see that we are somewhere closely doing the same thing that we did in basic exec, right? So we declared exec locals, we use the exec code in line number 5 with the exec locals dictionary, and then we are printing it. So exec locals is basically a dictionary, right? And here we are trying to get the results from the dictionary. So basically we are telling that if you go here, you will be wondering, okay, the Python 3 code used to interpret in the Docker container. So this is actually a mistake, right? This is a mistake that I made because I copied it directly from the Crew AI tool implementation. So this is what it is, but what I want you guys to look at is the always print the final result and the output of the code. So you see this particular command or this particular request to the LLM will make the LLM to write the code in such a way there is a result in the output. So if you go back, you will see there is a result in the output. You see this, right? So because of this result, we are able to get this printout as 55. I want you guys to dive into this code a bit and try to play with it using different kinds of problems and see how the code interpreter tool works. And also you can make this code exec crew little more interesting by adding additional agents and trying to send the output of the task, the code execution task, to the next agent, like as I shown here. So you can actually send that output. So the 55 can be sent to the next agent and you can make it to write. There is already a code that is present where I do this in case of the same folder. If you go, there is code exec write.py where I am using a Grok Llama 8 billion model and I am having a writer agent also. So you can do that, and it is using a file writer tool. Right. So I believe that you have got some pretty good idea on what is exactly happening in the backend. So it's a pretty simple logic that is getting applied, but you need to understand the basics. So yep, this is video 2, and stay tuned for the video 3 where we dive into the command execution. With that said, see you guys.